For design of pavement, we need to know the soil parameters. And for AASHTO method, we are interested for MR, which is modulus of resilience or modulus of velocity testings. But the thing is, whatever is the modulus of resilience or modulus of elasticity of soil changes over time. That is for climatic actions like January, February, March, or separate months have separate climatic actions. In some period of an year, there might be cold, and in some period of time, there might be a rainfall. In some period of time, there might be uh, warm season. So the modulus of resilience value changes over time. So here we are to find out the effective road bed soil resilient modulus. And for that, what we will design for pavement design. Another one that is subgrade reaction. We use this parameter for a rigid pavement design K. You'll see the later. However, the first thing of finding MR, that is to find out relative damage. There is a formula for that. That is, we call that mu f, and we have a formula for that. That is totally dependent on MR value. And there are separate formulas for relative payments. One is for flexible payment, another one is for rigid payment. For flexible payment, the formula mu f is 1.18 multiplied by 10 to the power 8 mr to the power minus 2.32. The thing is that we will put these values for MR. Let's say 15,000 of value of MR, and we'll find out mu f, and we'll get a value of say 0.02. And the later month, that is 28,000, for that we'll get a value of 0.006. And I'll be getting the values for me for all the months. That's the 0.003, 0.001. That is 12.9. Calculate with me. You'll learn quickly 4.35, and for that 1.7 and 1.01, and that is 0.62, that is 0.39. I have two more months. For that I didn't calculate earlier. I will calculate it now, and the formula is 1.18 10 to the power 8 multiplied by MR. I'm putting it as X and calculated 2.38, and then I'll put the value of 4600, and I'm getting a value of 0.37 or 0.38, whatever you said. And for 4500, I'll get a value of, let's say, 0.40. So now the thing is that you will sum all the values, and you will get a value of around 21.78. I will take an average of it. If I take an average of it, I will divide it by the number of months, that is 12. 21.78 divided by 12. And for that, I will get a value of 1.8157. Well, from this data, now you can find out the MR value. How? If we are interested to find out MR value, we'll take the relative damage, average relative damage, and we'll use this equation. Let's say now we want to find out the effective road bed soil. Let's say this is our effective one. So we know the U F bar value, which is 1.815, 1.815, 1.18, 10 to the power 8 MR effective to the power minus 2.38. So from here you can find out the MR value. If we solve the equation 1.815, 1.18 times 10 to the power 8 multiplied by x to the power minus 2.38. Now solve this, you will get a value of 23312. So that is 2332, something like this. So this is the answer for MR, and it has a unit of PSI. So this is your effective one, and you will use it for how do you say flexible pavement. Now let's say you want to find out the subgrade reaction for design of rigid pavement. For that, first of all, you find K value. It has a name. I have forgot that. Maybe yeah, it's called subgrade reaction. We'll find out subgrade reaction for all the months, and there is relationships between. Let's say it is for math 1 part. Let's say it is for math 2 part. That is, there is a relationship between subgrade reactions and MR value. If you divide MR value by is that 19.4, yeah, 19.4, then you can get a K value for all the months you're interested. Say MR value is X 19.4. So first month it is 15,000, so you're getting a value of 773. So for every MR value you'll get a value of K. So it is 1443. Later one is 20102677, or 2577. Pardon me. Yeah, it looks like 2577. I don't know. Let's check it. So the MR value was 50,000. 2577. Sorry. 2577. Well, for May, the K value is 5182, 123, 154, 191, 232. And we have 2 more months left. One is November, and for that I have MR value of 4600. So I'll get a value of 237. And for the month of December, I have a MR value of 450, and for that I have MR value, sorry, K value of 232. So this is subgrade reaction for a particular month. So January this, for February this, but I need the representing one for which I to design my pavement. And for that, how do we do? We found mu r, relative damage again, and that is for rigid pavement, and the equation is pretty long. That is, mu r is equals to d. This is the depth of your concrete slab, 0.75 minus k to the power point is 0.25, yeah, 0.25 multiplied by 0.31, and the quantity will be powered by 3.42. And in our case, the thickness of pavement, the rigid pavement is 9.5 inch. So I'll build an equation like parenthesis 9.5 to the power 0.75 minus k, and here the k is variable. I'll put k values of a different month, and it has a power of 0.25, and I'll multiply the quantity of x to the power 0.25 by 0.39, and I have a power of the quantity of 2.42. So I'll put cable of for the first month, that is January 773, and for that I will get a mu r of 63. It's a relative damage for particular month January. And similarly, I'll get for February, that is 43, and the later one is 34, 27, 155, 139, 126, 118, 111, 104. Previously, I didn't calculate for November. Now I'll do that. 237. I'll get a value of 103. For the later one, I'll get similar kind of value, 232, and get a value of 104. Well, the thing is that, so it was 63 plus 43 plus 34 plus 27 plus 155 plus 139 plus 126 plus 118 plus 111 plus 104 plus I have more two more months, 103 plus 104. So it is 1127. Sorry, it is 1127 divided by 12, and you will get a value of 93.9. 3.9. Well, you have now k bar. For k bar, you will find out mu bar. The thing what we have calculated, that is mu bar. We have summed mu bar or u bar, whatever it is, and we have divided it the number of frequencies, that is 12. So now we have this mu bar, that is 93.9, and we have that is 9.5 to the power 0.75. We want to find out the effective k value, what we don't know yet, so I will keep it as it is. Here you will get a value of k effective 310.5 something, and it has a unit of pci, pound per cubic inch. So, in short, this is the math. First of all, you find MR effective for flexible pavement, then you find K effective for rigid pavement. This math, what we have learned that in every month or over time, the KR value or MR value changes. So we are here to find out the effective one that we will use for our design, and these maths are really important for exams.